So this is an interesting question. I did let it slip in a previous video that I have published a novel nuclear reactor design of my own. And it's interesting. It's what would be called a hyperbreeder. And what that means is that if you start it with natural uranium, that it will actually breed to the point where it will become prompt critical. I'll put some links in the comments if any of you want to go back and look at the papers, but yeah, published a few papers on it. The idea being that you can do some niche type work with this. If you want to do a power reactor, I've got a student that's looking at it for other applications that are really interesting. But what happens is that you start off with using plate fuel. So the uranium is in the form of a metal that is a slab, it's a plate. And what that does is it gives what's called a big kick to your fast fission factor. What that means is that when a neutron is born in the fuel, it's more likely to interact with uranium-238, even though it's natural uranium, meaning that you have very little of the fissile uranium-235. A neutron that's freshly born in fission can fission uranium-238 if it is not moderated, if it doesn't bounce into anything else first. So the point is that the uranium-238 will fission and give contributions to the neutron economy. On top of that, it uses beryllium slabs for moderation. And the beryllium slabs are large enough that the neutrons, a large fraction of them, will spend the majority of their time in the beryllium instead of in the fuel. So once they leave the fuel, they spend a lot of time in the beryllium, and so they miss what's called the resonance absorption lines of the uranium-238. And the reason that's an issue is if the uranium-238 absorbs a neutron that's bounced around a little bit, it's not going to fission, it's just going to turn into a neutron poison. And so there's a better neutron economy when you use the beryllium slabs. And then you get water out with an optimal layer of water thickness in there that is then used as the coolant. So it's a slab configuration, a repeating pattern, so that it would go beryllium, uranium, water, uranium, beryllium, uranium, water, uranium, beryllium, and so forth and so on. So it's a slab configuration that allows you to have some really interesting physics, because with modern light water reactors, you would not be able to generate one that would create breeding anywhere like this. As far as I am aware, there is not a reactor in existence that can breed like this one. And so it just very quickly turns the plutonium from weapons grade to reactor grade, because it's just breeding so fast that it just would do that. So it's interesting, but then again, I'm quite biased because it was my reactor. I had designed my idea. But thanks for the question. I hope you liked it.